Question 25 reads, find the average binding energy per nucleon of 2814 silicon and 3717 chlorine. Calculate to 4 significant figures. And it gives us the atomic masses here for silicon 28 and chlorine 37. So what we're going to do here first is we need to calculate the mass defect, and then once we have the mass defect, then we can use it to find the binding energy, and then thus find the binding energy per nucleon. So we're going to start off with the mass defect equation, which is the number of protons, which are 14 for silicon. We're getting that from the atomic number here. 14 protons times the atomic weight of a proton, which is 1.007825 U, plus the number of neutrons, which are also 14 because 28 minus 14 is 14, times the atomic weight of the neutron, which is 1.008665. And then what we're going to do now is subtract that from the atomic mass of silicon 28, and then this will give us the mass defect. So we're going to write that here, 27.976926 U. And then so this will give us an answer of 0.253943 U. And then once we have the mass defect, we can go ahead and plug it into E is equal to mc squared. And then we'll multiply our answer by 931.5 mega electron volts over speed of light squared. And this will essentially convert our answer to mega electron volts. So our answer here should be 0.253943 U times 931.5 mega electron volts. The speed of lights are gonna cancel out, and then is equal to 236.5 MeV per nucleon. And then so I'm sorry, this is not actually MeV per nucleon. This is just the total binding energy. And then so in order to find the binding energy per nucleon, we have to divide it by the number of nucleons. And so we'll divide it by 28 because that is the mass number, which is which contains the total number of nucleons. And then so this will give us a final answer of 8.446 MeV per nucleon. And then so basically you just have to repeat the same process for chlorine 37. For chlorine 37, what we're going to do is instead of 14 protons, we're going to look at the atomic number, which says that chlorine has 17 protons. So this will be 17 times the atomic weight for a proton, plus 20 this time, because 37 minus 17 is 20 neutrons. So 20 times 1.008665. That'll give us a value which will subtract the atomic mass of chlorine 37 from to get the total mass defect. And then once we have the mass defect for chlorine 37, we'll just multiply it again by 931.5 mega electron volts, and then that'll give us our binding energy, for which we can divide by the number of nucleons, which are 37 for chlorine. And then so if you do this, then you'll get an answer of C.